I'm just going to talk through some of the placement options, and I'm actually going to share with you a challenge versus sharing with you our answers. So every year we have maintenance dredging volume, so that material comes from the natural resuspension. We do that through and also through the outputs from Ross Creek, Ross River as well, despite the fact that they are severely limited to what they used to be historically. So we undertake that with different types of dredge material or dredges. So we have a trailer suction hopper dredge, which does the majority of our maintenance in our sea channel, outer harbour, inner harbour. We have a cutter suction dredge, which does the majority of the Ross River dredging, and then we also have a mechanical dredge that undertakes that activity throughout the year in various locations. So we do an awful lot of work behind the scenes to minimise our dredging. It's no secret, and it will be clearly advertised for any port. If you can minimise your maintenance dredging, that is your primary aim. So it's been one of the biggest costs for our organisation since inception, and continues to be something that we try and limit through various ways. As I mentioned, we have a whole range of areas that we dredge. I'm not going to go through them again. And current maintenance disposal occurs both on land and at the ocean dredge material placement area. So beneficial reuse options as it stands are land reclamation. Whatever your personal opinion is, it's currently defined as a beneficial reuse option. Construction fill, mine rehabilitation, so taking that material off site to fill the holes that mining do. Beach renourishment, shoreline protection and erosion controls, soil improvement for various reasons, habitat restoration, and also landfill site capping. So Ross River, we've got high quantities of sands, so that is a really good material for beneficial reuse. So we have a whole lot of range of uses that we can have for sands. It's got low potential acid sulfate soil, or low potential acid sulfate soil. So because it's clean sands, it doesn't have a lot of that ability to generate acid sulfate. And it's generally low volume. So we only dredge there every 3 to 5 years, depending on how fast the channel closes over. However, there is a legislative requirement at the moment that if we dredge it, it needs to remain on the port for port-related purposes. So all that material comes to shore. That's with the cutter suction. Mechanical dredge, so this is the work that our maintenance activities undertake throughout the year. That all comes to land. So that goes to our dredge material placement area on land. It generally has poor reuse properties. So by that I mean that it's got... What am I doing? Is that one? How about I just yell? Can you just wave at the back if it's not working, rather than clicking and carrying on? So in general, it's got low volume, so it's quite a small turnover component for us. It has poor reuse properties in the fact that it's silts and clays that have been mobilised, because we pump that to the reclamation area, and it does have the potential for acid sulfate soils. That can be managed, particularly because of the small volumes, but from a reuse property, it's not great, but that comes to shore. And again, we've got that limitation that it stays on port for port purposes. So the capital dredging, or the maintenance dredging undertaken in our channels and the outer harbour and inner harbour is primarily the trailer suction hopper dredge. I'm just going to share with you some of the challenges with that material. So in general, it's dominated by unconsolidated silts and clays. So that takes out some of the options that are listed earlier for reuse just outright. So we're not going to be using that material for beach renourishment on the strand. It's just not suitable for that purpose. Dewatering, so to bring that material to shore, you entrain about 80% water to 20% of sediments. So that material to shore is a significant area required to contain, but then also dry that material in the set period before the dredge is coming back again. So it's an annual maintenance. The final engineering properties of that material aren't great. So this is from an engineering point of view. Contaminant point of view, it can be used at a childcare facility. So contaminant-wise, it's actually very clean, but it's the reuse and the ability of that to maintain engineering properties, which is poor. So the other component, so the reuse for agriculture, for example, due to the nature of it, would require about 3 times the amount of sand to be combined with it to be classed as a typical topsoil. So again, you're then turning your 450 cubic metres into 3 or 4 times that volume that you then have to get off site every year. And again, don't forget that limitation that it has to be on port for port-related purposes. So this is just some of the options that are taken out just purely due to the nature of that material. So beach renourishment and shoreline protection erosion control are taken out of the mix. So salt content. It's a saline environment, we're not dredging. So a lot of the examples used from America are from their freshwater lakes. So that material can be brought onto shore and used for things like agricultural top surfaces, or even a bit like milling mud for us as a conditioner. Because of the salt content, that starts to limit the options. So yes, you can treat it, you can wash the salt out. With our water problems, council has hit us around the head with that option quite significantly in the past and said don't even think about it. There are options in that you can leave it through a wet season that actually naturally reduces some of the salt in it. However, then you get into this ability to actually dry the next round and have, again, the space required to dewater. So the space is a significant challenge. So these are ones that were taken out earlier, and then this is the salt component that's just not as viable for us. So as I said, we do have a large volume that's reoccurring, so we dredge every year. And again, just purely that volume capacity takes out some of those options due to the dewatering space for handling, transport, and again, that return period is actually a significant challenge. So if you're bringing this material ashore once every 5 years, you've got 5 years in which you can dry that, manage it, engineer it as whatever you need, and then actually have the time to move it off site. We don't have the time and we don't have the space. So Gabrumpers undertook some research in 2003 to 2015, and again that supported a lot of the long-term options for land disposal for maintenance dredging is a significant challenge in the World Heritage Area because of the availability of space. So Council has actually given us a letter, we have that on file, that says no, we can't use the volume of material for landfill, and in fact, no, we don't want any material for landfill, thank you very much. We're good in that space. So that leaves a few options. So these are the options that stand. As you can see, land reclamation is one of them. Should we be reclaiming forevermore in a World Heritage Area? No. But that is one of the options that sits there. Construction fill, so yes, it's potentially viable. There's a range of engineering properties that would need to be addressed. Again, not addressing that, not moving it off port for port-related purposes. Mine rehabilitation, look, careful consideration is needed for that. It's got a saline component, and you need to be making sure we're not then transferring and causing a groundwater or a surface water issue at the mine because you're now introducing salt to an environment that doesn't have salt in it. Habitat restoration, so yes, there's potential for some of those, particularly in your wetland saline areas, but again, careful consideration of what the need is, what the ability of the material to stay on that location is, and also is that material suitable for whatever the intended purpose needs to be considered. So other than reclamation, there is a limitation of suitability for available land around. That doesn't mean we don't continually look at it. So the answer today needs to also continue to look at what technologies, what improvements, what else are we learning as we go. So for ocean placement, these are considerations that go into that. It's not just, oh, we'll just pick this area. So what is the capacity of that location? So the current DMPA, which is I'll show next, is about 12 square kilometres. Sorry, DMP is the dredge management placement area, or dredge material placement area. Seabed substrate. So where you place that material, in theory, should be similar substrate. So placing mud on sand is not necessarily the best outcome because that material behaves very differently. So there's a like for like strong preference through the process. Dispersal or retention site. So obviously the more retentive a site, the more that material stays in that location, more preferable. However, in the inshore lagoon of the Great Barrier Reef, the options for that are significantly limited. So the majority of locations are dispersal to varying degrees. Obviously, that's an area that continues to be looked at. Ecological habitats, so what's around the area. Fisheries, shipping, so what are the other uses? Including the zoning, so the Great Barrier Reef Marine Park zoning falls into that. Planning and amenity, so this is where it also comes into the tourism component and all of those. Project cost, so ultimately, yes, it still has to fit within a component. And proximity, so the further away it is, the further the dredge has to go, the longer the dredge campaign. So it's got a whole range of components and compromises that need to fit into it. So this is where the current dredge material placement area is. And this is the current depth of it. So the reason it's located there, it is in one of those earlier disposal areas that Kim showed. But what happened in 1993 is we identified pushing that into the deepest area, so past the 10-metre contour, meant that it resuspended significantly less. So yes, it resuspends, but it resuspends when everything over 11 metres is resuspending. So this is the 11-metre contour, 12, 13, 14, 15. So we actually have quite a deep placement area. Historically, so up to about 2 years ago, we had a requirement that we had to evenly spread across that placement ground. That was put on us by Department of Environment. That's now come, there's a bit of a change, and as long as it's not mounding, we can actually preferentially place in those deeper areas now, which is a better outcome because obviously deeper area, less resuspension. So, as I said, I haven't gone through all the ways we do minimise dredging. We do. We are constantly trying to achieve that. We do beneficially reuse as much as we can, which is particularly those good quality materials. We do have a long-term dredging and disposal management plan. So last time we really significantly revisited the entire program and the entire options. We had a massive reclamation. That reclamation is now full. So we're revisiting that entire process again. We monitor technology and opportunities, so there's a whole range of things that continually evolve and we incorporate those, and if we need to change, we change. We monitor and work with our regulators regarding barriers, so occasionally there's some barriers that aren't intended to limit some of the disposal placement options. So for example, the staying on port for port-related purposes. However, there's some other challenges with that. So we have to prove we're not impacting quarries if we're using our material for other components. As I said, and I guess this is where Ross and particularly WBM, there's always things we can improve and always things we learn. That happens regardless, and if we're not learning, that's a problem. And we do revisit our options regularly. So that's just a really quick overview. I'm sorry, but I didn't want the red hat. So